Hello, welcome to Google. Welcome to the August Angular Meetup. Today we have a very special guest, Gleb Bahmutov. Did I kill it? Sorry. So we're going to talk about testing ngDescribe. So it's a very interesting talk for all of those people who enjoy testing. And if you don't enjoy it, probably you can learn a few tricks because he's going to simplify your life. And let's start.
Thank you, Andrea. Yes, I'm Gleb. I work at Kensho. We have a couple of Kensho peeps here. If there are people from Amazon, come talk to us. Well, not soon enough. Anyway, snap back, people. We're going to be talking about testing, and I know testing is not glamorous. It's often boring. What's my favorite slide? It's a chore. Nobody goes to be a developer and says, I want to test your stuff. I want to see if it breaks. But we have to do it. Often it's a drag. You want to add a feature, and all of a sudden, like, I have to make the test pass again. Why they're failing, I have no idea. Remember a time when we went to a client and they said, next year, release a new version. Don't add any new features. Just write a bunch of unit tests, and we'll pay you a lot of money. Like, this never happens. You never sell the tests. This slide is confidential. Please do not distribute this. This is how Kensho is making money. We write working code, we iterate, customers ask for more stuff or something is broken, and then we profit. Again, very confidential. I haven't said tests yet, right? Oh, I forgot about that. Well, it's kind of implicit, right? The code has to be working. If something breaks, the customer doesn't care if you wrote tests or not. They actually said it's broken. You have to write tests to keep it working. Another confidential slide, please do not distribute. This is our iteration model. We write code, we go to the customer, we show code, and we ask for something else or an adjustment. We refactor the code, we put new features. We get paid. No, we don't. We forgot to write tests. We have to keep the app working. If you practice test-driven development, which we sometimes do, you write tests first, and then you write code, iterate, get paid. After a while, after a year, maybe a couple months, you notice that you'll write a lot more tests rather than new code. That means getting paid becomes tiny. So before we can refactor and sell more to the customer, we have to write tests. And another thing, writing tests directly cuts into our bottom line. Every hour spent unit testing, that means an hour spent not selling something new. Okay, so this is very advanced, but here's the solution, effective testing. You can write fewer tests, and I'll point how to write them, and then spend less time writing each unit test. And that's the bulk of my presentation. Okay, background. Unit tests in Angular are small, run very, very fast, usually mark all the dependencies. There's a perfect tool called Karma. It used to be called Testacular, but end-to-end tests. This is something we're not going to cover. But the people at this Google office, like talk to Andrea, he's the guy in charge of Protractor. We're not going to cover it. If you never tested JavaScript code, this is how you do it. Let's say you have a function add. You start a test file, something called spec. I like behavior-driven development, so you describe a behavior. In this case, you describe addition. And then you add a couple of unit tests. For example, it adds numbers. You say, when I add 2 and 3, I expect the result to be 5. It concatenates. If I add foo to bar, I expect the result to be foo bar. If you never tested before and you want a good introduction, read Start Testing in 10 Seconds and 1, 2, 3 Tested tutorial. That goes through the whole thing from scratch. Karma. This is what we use for unit testing. It's an excellent tool. Here's how you install it. You install Karma itself. You initialize the Karma configuration. And then you install your Jasmine or Mocha or whatever framework you want. QUnit, it has adapters for everyone. Configuration. something you do using Karma init. It's very fast. You pick the framework you want to use, like Jasmine or Mocha. You specify which files Karma should load at the start. In this case, add.js and add spec.js. And that's it. In the browser, in this case, it will start Chrome. I actually like Chrome. Not because I'm at Google Office, but I actually like it as a browser. Firefox, I'm just a friend. It runs, it tells you that the 2 unit tests pass. Excellent. Here's how to effectively target your unit test. You don't want to be blindly writing unit tests. Maybe you're testing the same feature over and over, but not the particular other piece of code. So you want to get code coverage. Very easy using Karma. npm install Karma coverage plugin, add coverage preprocessor, and coverage reporter. That's it. You run the test again, and it generates a nice HTML, JSON report. In this case, by file, tells you everything that was covered or not covered. In this case, everything was covered. My function add was executed twice. My unit tests were executed once. I usually don't compute coverage for unit tests. It's kind of like noise. I expect all of them to execute, so I only concentrate on actual source code. So, effective testing. So I briefly covered how to be effective and target the unit tests. But which particular files do you want to target? Another tool, JavaScript complexity. So you run the JavaScript complexity tool over all your source files. You compute unit test code coverage using Karma coverage plugin. And then you get something like this. So for each file, you get a metric. Let's say it's lines of code, any kind of complexity metric. So in this case, foo is 100 lines, bar is only 10 lines. They covered by unit test approximately at the same ratio, 25 to 20%. So where should you add unit tests? My assumption is that you should test the larger file. It has a lot more code. It's probably more complex. So we have a tool, it's not really released yet, called Risk Map. It shows a tree map of all your source files. The size of each rectangle is proportional to complexity, number of lines of code, for example. The color from red to white shows the code coverage from unit tests. White means completely covered by unit tests. Red means completely uncovered, 0% coverage. In this case, it's easy to spotlight. You should test that file. It's huge, it's bright red, no unit test, and it's complex. So maybe you can target this particular file. Or something simpler. We build a whole bunch of bundles by feature. In Angular, it's easy to build bundles and use all of them. And then you compute coverage by bundle. And then you say, well, this feature is about to stay in, right? Customer liked it. We never tested it. Now we should increase code coverage in that particular bundle. Bonus, we have a tool for live code coverage, so you can set a proxy between you and your website, and it will grab the coverage on the fly, so you don't have to do anything to your website. And then you can kind of combine unit tests and live coverage. So look at the slides. All the links are there, and I'll be happy to answer questions. It's not really the focus of my talk, so I'm going to skip over these things really quickly. So we can target unit tests better. We still have to spend time writing each particular unit test. So let's see how we can actually spend less time. So I came here on a Acela, kind of look like this. Maybe not. If you go to AngularJS.org, right, the homepage, right, that's where the magic is. And you scroll to the bottom of the page, and it says testability built in, right? So it's a big selling feature of AngularJS framework, right? It's right there on the homepage. And yes, AngularJS is more testable than Dojo or Kenda UI or any kind of framework before its time. And interestingly, this is code directly copy-pasted from the page. Right before we talk about testable, we talked about injectable. It's kind of interesting that you realize that in order to be testable, which is a big selling feature, the dependency injection is very important. They talk about dependency injection right before they talk about being testable. So a takeaway, AngularJS is testable in the dependency injection mechanism is directly responsible for the testability. And now let's see how it works out in practice. Really simple example. We have a module to do app. We have a controller to do controller. It has scope. Magically appears in my application. I never had to construct scope. Angular does it for me. And at the start, the scope will have a list of to-dos with 2 items. That's it. Okay, so I'll start my description. And I'll ask Angular mock module to do app. So far reasonable. No surprises. Boom. Big chunk of code right there. I have to write and inject, and then underscore dollar controller underscore dollar root scope. What the hell is going on here? So I'm starting my unit test, and I have to call root scope dollar new. Who knew that JavaScript has dollar new, right? No one knew. And then I have to call controller service and pass scope. And only after I wrote all this code, I can do a single assertion. Right? That's the point that's really, really difficult. That makes me sad. If you want to be hired by Kensho, you have to get REST development references. Okay, so the takeaway is that the dependency injection, that's a huge point of Angular. It just works. You just say what dependency you want, and it appears magically. During unit tests, works against you. You have to do it yourself. You have to know how to inject things. Scopes, right? Things that tie controller to the DOM, to the view, they just appear, they just work. They just link to each other, to the parent, to isolate scope. All of a sudden, during unit testing, you have to do it yourself. You have to deal with details that you never had to deal during normal development. So here's what I want. Injecting and saying, I want this module seems reasonable. I don't object to that. Knowing how to inject things with underscores and dollar signs, that's unreasonable. Knowing how to create a controller from a root scope and how to pass things, that's unreasonable. The same unit test using the library that we wrote called ngDescribe. We just say, I want this module, I want this controller, and I can start testing right away. The only word that comes to mind is beautiful. In italics. It has to pop up in italics. During application writing, controller and scope are just created. You don't have to do anything. Using ngDescribe, the controller and the scope will be created magically for you. Kind of the same idea. We want to hide all the details. Jasmine 1, 2, Mocha, they all work nicely. We only use pre-testing callbacks, describe before each and after each. And if you have other things, like Mocha and Jasmine provide ways to skip a test, to only write a test, or run something before everything, they all work. ngDescribe does not depend on them. The API is very, very simple. It's a single function that takes a single object of options. People kind of debate what's the best unit testing framework. Just by a quick show of hands, can you ask who prefers using QUnit? Come on, there must be at least one. Okay. One, excellent. Thank you, Lindsay. I did pay them. And it was worth it. Did you see that? Who uses Mocha? Excellent. What about Jasmine? Okay, people who raise hands. Talk to people who use Mocha. Why? Why you should switch today? We prefer Mocha, even though we use Jasmine a lot, with our own library of lazy assertions. And what this means in practice is that usually you write your assertions or your expectations like this. Expect foo to equal bar. and then you provide a single error message in case it fails. And you write foo is, and then actual foo, so when the unit test fails, you actually get useful information. If you use lazy assertion, you can say LA for lazy assertion, depth foo equals bar, so you don't have to know any particular syntax, it's just an equality or any predicate. And then you can pass as many concatenate, there are no limits. We also wrote another interesting library of predicates that has everything you might want for checking stuff. So you can have check equal, check function, and so on. We test ngDescribe against all versions of Angular 1. Angular 2 is so new, and the dependency injection switched so much. We'll see when it stabilizes, we probably will port ngDescribe to Angular 2 as well. So far, there are no plans. We test the project pretty rigorously. I'm going to skip this because it says skip. A couple of examples. Built-in filters are very simple to test. You just inject filter. It comes from module ng, right? The standard module. It will be available by default, so you don't have to say I need module ng. And then you can just grab it from dependencies. For example, lowercase, and you can assert it. Asynchronous stuff is very simple. Just a callback done. So for example, in this case, you have a $Q service, so a promise. And when it's 42, you want to see if it's resolved. You have to call root scope digest to kind of make a digest cycle turn. Kind of a lot of boilerplate because you have to inject stuff. So we provide a shortcut for you. So dependencies has a special method called step. So instead of remembering, oh, I need a scope or a root scope, and I have to call digest, you can just say step, and it will move on. Writing custom directives in Angular is, I think, the best feature. You can literally extend HTML with new stuff. We were discussing this yesterday. I think it's the greatest feature that we developed for unit testing, but it's kind of underscored. But once you kind of start using it, you cannot stop. So simple expectation. I expect foo to equal string bar. So what happens when it fails? You get error message, but it's empty. That's it. It's just the test failed. So you write something like this, single message called expected foo to equal bar. Okay, this gives you, a message, but what was value of foo, right? I know it wasn't bar, that's for sure, but what was it? Was it undefined? Was it, bar 2? Okay, so you write something like this, expected foo, value of foo to equal bar. Gives nice message. But we're writing boilerplate code again. And now you write a lot more expectations, or a lot more assertions than boilerplate code, but each expectation becomes very, very verbose. And you're literally repeating yourself. My expect foo to equal bar, expected foo to equal bar. You're literally repeating yourself twice in every expectation. Not good at all. No one sees your brilliance. So we have a little library called lazy-s helpful. So lazy-s stands for lazy assertion, not how we consider ourselves. All you have to do, surround your ngDescribe with help describe. It's a single function, just a callback. And then you write your assertions like lazy-s depth foo equals bar, and that's it. You don't write any test messages. You don't write value of foo. What happens instead is if it fails, it will give you a message like this. Condition depth foo equals bar, and the value of every dependency, every variable you refer to in your condition, just magically. You can spend less time writing each unit test by using a helper library. And now let's be philosophical for a second. So we wrote ngDescribe. It kind of replaces Angular mux. It uses Angular mux. But in reality, we never deal with Angular mux directly. Angular mux come from Google. And then you think, why you think you're smarter than the Google folks, right? Why should you write something like this that adds to the Google way of doing things or replaces it, right? Aren't you kind of saying that you guys are better developers? And if you have an idea or a pain point in your development cycle, do not be afraid to write a project that solves your need and make it open source. Because if you have a pain point that you hit over and over, other people probably do hit as well. But your pain point might be very, very different from Google's developers' pain point. So Angular Max is excellent. But Angular folks probably never, or they remember the syntax very, very well. So they never had to hide it. And if people did not say, I'm actually going to solve my problem, make it open source, and it actually becomes better than Google, we would not have UI router, we would not have ngDescribe, or Angular Formally, or a bunch of libraries that actually do something that Google library does, but much better. Just don't be afraid. It's easy. Google is not everything. It's just all the alphabet. And Kensho soon will become symbols. But, if you want to start from scratch and kind of see, from zero, an approach to AngularJS testing using ngDescribe, just read this blog post. ngDescribe README has all the API examples, all different situations.
So I was just wondering why we didn't talk about end-to-end testing today.
Well, end-to-end is really a different beast, right? And even according to Google's own chart or pyramid of tests, 80% of tests are unit tests, right? They run very, very quickly. They don't need the whole browser. They usually don't run against the server. They have to run fast. So the majority of our time is spent writing unit tests. End-to-end is completely different animal. And I'm not the best to speak about end-to-end. Protractor is great. We use it. We use Protractor performance tools. Probably, Andre can talk about that much better than I can.
And does ngDescribe work at all within Protractor?
I would expect so. I don't see why not. Standard Jasmine works, so definitely. Albik, I can say it's the best thing to use inside the Protractor. Just unconfirmed yet.
Yeah. A quick question.